Welcome back to The Explainer. Today, we're drawing out the absolute core concepts from Week 3 of the PyLadies Rivers Python course. If you've been following along with us, you know this curriculum is just incredibly well designed for absolute beginners, taking you step by step into the wild world of programming. So today, we're firing up our virtual whiteboard to talk all about decision-making with Python.
And hey, we aren't doing it alone. Channeling Ada, our brilliant PyLadies AI mentor, we're going to break this whole thing down step by step. Her philosophy is super simple, right? You absolutely do not need a computer science background to succeed in tech. So, we're going to make this incredibly accessible, ensuring you can easily understand the logic, even if you have zero programming background. So here is our 6-step roadmap for today. We'll start from variables to decisions, then cover Booleans and operators, move into the if, else flow, look at nested and logical conditions, learn Python's rule of indentation, and finish up with a summary and next steps.
Let's jump into Section 1, from variables to decisions, Week 2 to Week 3.
Okay, let's really dive into this comparison. Last week was all about variables, data types, and operators. You were essentially teaching the computer how to store static facts, things like someone's name or maybe calculating their age 10 years from now. It was a great foundation, but honestly a bit passive. But shifting gears to Week 3, this is where the magic happens. We are moving into conditions. We're literally teaching our programs how to actually think and respond dynamically to entirely different situations, rather than just blindly repeating what we typed.
Moving right along to Section 2, Booleans and operators, the foundation of logic.
To teach a program to think, we first have to give it a foundation of absolute truth. And that brings us to the Boolean expression. By definition, it's a statement that evaluates to exactly one of two states, true or false. There is no maybe in Python. Think of a Boolean expression kind of like a simple light switch on our whiteboard. It is either perfectly true, meaning the light is on, or perfectly false, meaning the light is off. It's the ultimate binary decision.
But you might be wondering, how do we actually flip that switch? Well, we use comparison operators. You briefly met these in Week 2, but today they really become our main tools. They are the mathematical building blocks we use to evaluate conditions and create those true or false Booleans. For instance, double equals checks if two things are exactly the same. The exclamation point and equal signed together, that means not equal. And of course, your standard greater than or less than symbols. By using these, we can ask the computer a question like, hey, is the score greater than 90? And the computer will answer with a Boolean, true or false.
All right, Section 3, the if, elif, else flow, where we build decision trees.
Now that we have our true and false building blocks, let's map out a real decision tree. Let's look at a super practical, everyday example straight from the PyLadies curriculum. Calculating a student's letter grade based on their exam score. Listen, if a teacher has 100 exams to grade, they do not want to sit there manually deciding every single letter grade. They want to just feed the computer a score and have the program automatically decide if it's an A, a B, or an F.
And this right here brilliantly illustrates how Python handles decisions. It reads the flow step by step, straight from top to bottom. First, we use the if statement. This runs a block of code only when its condition is true. So, if score is greater than 90, grade is A. But what if that's false? Well, that's where step 2 comes in, elif, which is just Python shorthand for else if. This lets you check sequential backups. Elif, the score is greater than 80, grade is B. And the cool thing is you can chain as many elif statements as you need for C and D grades. Finally, step 3 is the else statement. This acts as your final fallback if literally no other condition is met. If they didn't get an A, B, C, or D, the else catches them like a giant safety net and assigns an F.
Section 4, nested and logical, dealing with complex conditions.
Let's see how this all builds up when our everyday decisions require a little bit more nuance and multiple layers of checks. For instance, take another PyLadies exercise, checking if someone is actually eligible to vote. To vote, checking just one single fact isn't going to cut it. You need to meet the age requirement, usually 18 or older, and you absolutely must possess a valid ID. Two totally separate conditions must both be true for the final outcome to be true.
So how do we actually write that in code? One way is through nested conditions. Just like Russian nesting dolls, you are literally placing one if statement directly inside another if statement. If you were drawing this on our virtual whiteboard, you'd draw the first if block checking, are they 18? If that evaluates to true, the program steps inside that block, where it immediately hits a second if block checking, do they have an ID? It's a really great way to check highly specific sequential scenarios.
Alternatively, we can streamline this full shebang by using logical operators.
This allows us to combine multiple requirements into just a single, clean line of code. The AND operator means both conditions must be true. So age is greater than or equal to 18 and has ID. The OR operator means at least one condition must be true, like checking if someone is a member or a guest to allow entry to a club. And the NOT operator simply reverses a condition. These logical operators are just incredibly powerful for making your code super clean and readable.
Okay, Section 5. Python's indentation, structuring code blocks. Before you run off and start building these sophisticated flows yourself, we really need to highlight an absolutely crucial structural rule for writing Python code. The point is this: Python is incredibly strict about spacing. You can kind of think of it as the ultimate grammar police. Just like paragraphs are used to group related thoughts in a physical book, Python relies on precise indentation, usually exactly 4 spaces, to understand exactly which code belongs inside your if, elif, or else blocks. Getting it wrong, even by a single space, triggers a strict indentation error, and your program will just immediately crash. It literally forces you to write visually clean, organized code.
And that brings us to Section 6, Summary and Next Steps, wrapping up Week 3. Let's step back from the whiteboard and review the powerful concepts you've mastered today. Let's run through our checklist. You have successfully learned how to make programs respond intelligently using Booleans for true/false logic, comparison tools to evaluate your data, structured if, elif, and else flows to route those decisions, nested logic for complex checks, and of course the correct indentation to keep it all running smoothly. You have essentially given your code a brain today.
Now, if combining all these operators and conditions feels like a lot to take in at once, just take a deep breath and remember Ada's advice from the curriculum. Every expert was once a beginner. The PyLadies Rivers community is completely built on supporting one another. You do not need a computer science background to master this stuff. You are taking all the right steps by learning piece by piece, and you should definitely celebrate every small win along the way.
But before we wrap up today, I want to leave you with a bit of a provocative question. Today, we taught our programs how to make an intelligent decision once. But what if you have a list of 100 students and you need to calculate grades for all of them? You certainly don't want to copy and paste your if statements 100 times. No way. So how do we solve that? Well, we're going to answer that exact question next time when we dive into Week 4, where we introduce loops and teach our programs how to repeat actions entirely on autopilot. Thanks so much for joining me on The Explainer today, and keep on learning.